Hi, my name is Sean Munir, and my topic is barriers to using natural gas on passenger vehicles. So first of all, what's the motivation behind using natural gas in cars? For one thing, it's highly abundant. With reservoirs such as the Marcellus Shale and new drilling techniques such as horizontal drilling and hydraulic fracturing, we have access to a tremendous amount of natural gas that was never before available. In fact, even if we converted every car to run on natural gas from gasoline, we would still have enough natural gas to last us well into the next century. Because there is so much natural gas, it's also relatively affordable. The price of natural gas per gallon of gasoline equivalent is anywhere from 80 cents to $1.50, making it 1/2 to 1/3 the price of gasoline. Additionally, natural gas is cleaner than gasoline, emitting 20% less carbon dioxide and 25% less greenhouse gases. Now that we've talked about some of the advantages of using natural gas as a transportation fuel, let's take a look at some of the challenges of doing so. One of the biggest ones is refueling. There's somewhat of a supply and demand paradox in place. Natural gas refueling stations aren't being built because there are not many natural gas vehicles out there, and natural gas vehicles aren't being built because there aren't many natural gas refueling stations to fill up at. However, there are some natural gas refueling stations, and that's because it works very well in one specific market, which is fleet vehicle operations, such as buses and taxis. This is because all the vehicles are kept in and report to one central hub, and so it's feasible to have a refueling station there. For passenger vehicles, it's a different story. You can't just drive down the road or take the next exit to refill up on natural gas. What if there was a sort of home-based fueling station for consumer cars where you can literally refuel your car at home? Let's take a look at that possibility. Millions of homes across America are already using natural gas to heat their homes, so why not use that supply to fill up natural gas vehicles? Unfortunately, it's not that simple. The natural gas used in cars is compressed, meaning it's highly pressurized. The natural gas that's delivered to your home is only half a psi. The pressure required by a CNG tank is 3,600 psi, which means you would have to have a compressor, and that can cost between $4,000 and $5,000. Additionally, the storage of compressed natural gas at your home is forbidden by the law. This is a safety measure taken by the National Fire Protection Agency due to the high flammability and explosion potential of natural gas. That means that the compressor would have to be directly connected to the car's CNG tank from the home storage tank and compress the gas as it's refueling. This process can take up to 22 hours on current technology, but advancements are being made and plans for less expensive, high-efficiency compressors with refueling time of 8 hours are currently underway. Now let's take a look at what would need to be done to convert a car that was designed to run on gasoline to run on natural gas. Technically, it's not difficult. It only requires a few replacement components along with some basic software tuning. The bigger barrier is legal compliance. The EPA Clean Air Act of 1970 prohibits tampering with or modifying a vehicle's existing fuel system. The only way to lawfully convert your car to run on natural gas is through the use of a certified technician known as a qualified system retrofitter. They're trained directly by the specific car manufacturer in the proper procedure needed to modify a specific model. These services are not cheap, however, ranging from $6,000 to $12,000. Finally, let's take a look at the parts you'll need for a successful conversion. It starts with a storage tank, number 1. The fuel flows out of it through a regulator, number 2, which steps down the pressure from 3,600 psi to 125 psi so that it can flow through the fuel rail, number 3, and ultimately be used by the injectors, number 4. Number 5 is a wiring harness that sends information about the throttle position to the fuel computer, number 6, which then decides how much fuel the injector should deliver. This information is fed through a second wire harness, number 7, to be relayed to the adapter, number 8, which ultimately controls fuel flow from the injectors.